Please check it in your notes. Have we covered this slide? A solid ionic compound is NaCl, and it is formed like the ions here. They are arranged in a regular lattice. Okay, alternating positive ions and negative ions are there in a ionic compound, and they are held together by strong ionic bond, right? Are you there?
Yes, ma'am.
Okay. So have you please open your notebook. Now today we'll cover about the solid molecular covalent compound. Example of a covalent compound is water. If I ask you about name a covalent compound, it is water. Covalent bond, it is formed by sharing of electrons, right? So we have already learned the covalent bonding in H2O. Check it in your notes. That hydrogen have one electron. This hydrogen also have one electron. Oxygen have 6 electrons. Valence share in the valence share 1, 2, 3, 4, 5, and 6. So this hydrogen completes its duplet with sharing one electron with oxygen. This hydrogen also completes its duplet, while the oxygen shares one electron from both the hydrogen and completes its octet. Okay, so what is happening here? The sharing of electrons. And we have learned that sharing of electrons is covalent bonding. Remember?
Yes, ma'am.
Okay. So in ice, which is the chemical formula is water only, H2O, the water molecules, they are held in a regular lattice like this, but the forces between them are weak. So the forces between them are weak, they are not as strong as the forces between the ionic bonds. Okay, forces between the ionic bonds are very strong, but the forces between the covalent bond, they are weak. Lattice grows in all the directions, revealing a crystal of ice. These grew in an ice tray in a freezer. Okay. So, in ionic compounds, you have to remember both these points that in ionic compounds, the particles, or you may say the ions, they are charged. Okay, for example, sodium chloride. Sodium is also charged, Na plus, Cl minus is also charged. So, due to the charge in them, the forces between them are strong. They are held together by strong force. And in molecular covalent solids, the molecules are not charged. For example, H2O, no charge is there. The forces between them are weak. Okay, so the forces between ionic bonds are very strong and forces between the covalent bonds are weak. Is it clear, the difference?
Yes, ma'am.
Okay, so please write it down. Are you writing?
Yes, ma'am.
Very important properties of ionic compound. This question may land up in your exam for 3 marks. You have to write down the properties of ionic compound. So we understood what are ionic compounds, how to make the ionic compound, right? Now what are their properties? First property is they have high melting and boiling point. Why? Because the forces between them are very strong. So it requires larger amount of energy to break them. That's why they have high melting and boiling. Second is that they are usually soluble in water. So you can consider the example of your table salt. It is easily soluble in water, right? NaCl. It is your salt. It is easily soluble in water. Third point is that ionic compounds they conduct electricity only when they are in molten state or when they are dissolved in water. You can say when they are in the aqueous state. Aqueous means where the solvent is water. So there are three properties which are very important for you to remember, that they have high melting and boiling point. Usually they are soluble in water and they conduct electricity. Why? Because you know that they have ions, right? They have charged ions. So due to these ions, they conduct electricity, but only in molten state and or in the dissolved state, but not in solid state. Because in the solid state, they do not remain as ions. Is it clear?
Yes.
Write down.
Um,
So the properties of covalent bonds, they are exactly the different as we have learned about the properties of ionic compounds. So ionic compounds have high melting point and boiling points because they have strong electrostatic forces of attraction between them. Similarly, molecular covalent bond compounds have low melting and boiling point because their forces are weak. Second point is for ionic compounds, we have studied that they are generally soluble in water, but covalent compounds they tend to be insoluble in. Okay. Third point we have studied for ionic compounds that they conduct electricity only in molten state or when dissolved in water, not in the solid state. But covalent compounds they do not conduct electricity in any of the states, neither in melted state nor in dissolved state. Okay, so write down the properties of covalent. So if I ask you to differentiate between ionic compound and covalent compound, you can do this on the basis of these properties, right?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Reason. Degree Celsius, give a reason. So this is your homework question. You have to solve it, and if there's any doubt, you can ask me in the next session. Okay, first of all, try to do it on. So take a screenshot of this, or you have to write this.
I've taken.
Next is a diamond. Diamond is a giant covalent structure. We have studied about the ionic bond and the covalent bond, ionic compound and covalent compound. Now, let us study the giant covalent structure, which is diamond. Okay. So you can see here that carbon atom forms covalent bonds to 4 others, right? Because the valency of carbon is 4, its atomic number is 6, and the electronic configuration would be 2, 4. That means it can its valency is 4 and it forms 4 covalent bonds with the other atom. Okay. So here you can see that the center atom has 4 bonds and it is having a tetrahedral shape. Eventually, billions of carbon atoms are bonded together in a giant covalent structure. So this is just a tiny part of it. Otherwise, billions of the carbon atoms are joined together by a strong covalent. Okay. Result is a single crystal of diamonds. This one has been cut, shaped, and polished to make it sparkle. So this is after the refining process. It may look like this, but what is the basic structure of diamond? It is tetrahedral in shape, and you can draw this single unit. This is your single unit. And when many of these units combine together, so you have a very big network of this structure, and this is known as diamond. So this is the structure of diamond. So you can draw it in your notebook, the structure of diamond, their shape, and the structure. That means you have to write that in diamond, carbon atom forms 4 covalent bonds with 4 others, and each outer atom, then this is your outer atom, right? It forms 3 more bonds, right? Because one is connected to this one, and carbon can form a maximum of 4 bonds, right? So you have to write like this. So it forms a giant covalent structure like this, and this is just a single unit of this giant structure. If we talk about the properties of diamond, then it is very hard because each atom is held in place by 4 strong covalent bonds. Okay, you can say it is the hardest substance on the earth. If it is hardest, then obviously it has very high melting point, right? Approximately 3,550 degrees Celsius is the melting point of diamond. It can't conduct electricity. Why? Because there are no free electrons, no free ions to carry the charge. Okay, because conduction of electricity is carried out by free electron or the delocalized electron. But here all the carbon atoms are busy in forming bonds. That's why there is no free electron remaining to carry the charge. That's why diamond cannot conduct electricity due to its structure. Is it clear? The properties of diamond: very high melting point and boiling point. It forms 4 strong covalent bonds and it does not conduct electricity in the simple language. Is it clear?
Yes.
So you can draw the structure of diamond and then you can write down the properties of diamond. And it is a giant covalent structure. You have to write it in your answer. It is a giant covalent structure.
Mm.
Done?
Almost. Done.
Next are giant covalent structure. We are learning the giant covalent structure. So first we have learned about diamond. Second is the silica. So silica, the chemical formula of silica is SiO2. Okay, Si means silicon dioxide. It occurs naturally as quartz. Quartz is a mineral which is present in sand. So it forms a giant covalent structure, and the structure is shown here on the right side of the figure. Now, what is the structure? You have to learn this. Okay, that each silicon atom it bonds covalently to 4 oxygen atoms. You can see this diagram. Each silicon atom it is bonded to 1, 2, 3, and 4. 4 oxygen atoms. And each oxygen atom bonds covalently to 2 silicon atoms. You can see here with the oxygen atom. It is forming, it is making bonds with 2 silicon atoms. So this is also a very hard substance and it is having a melting point of 1710 degrees Celsius. Okay, so don't draw this structure. This is just for you know just for understanding how it is a hardest substance. Okay, how it is a giant covalent structure. You can draw this structure where it is easy to point out that here each silicon atom it is forming, it is bonding covalently to 4 oxygen atoms, and each oxygen atom it bonds covalently to 2 silicon atoms. Is it clear?
Yes, ma'am.
Okay, this is also very important. Get down and draw the structure. We'll study 3 giant covalent structures. First is diamond, second is silica, and third is pure graphite. Okay, so first of all, learn about silica, then we'll study about.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done.
The last giant covalent structure is graphite. So in graphite, like diamond, it is also made up of carbon atoms, and we can say that diamond and graphite, they are allotropes of carbon. Allotropes means two forms of the same element. Same element is your carbon here. Carbon is diamond and carbon is graphite. Only difference is in their arrangement. So diamond is the hardest solid on earth, we learn, but graphite is one of the softest. Okay, it is slippery. So you can see how different their properties are due to its structure. So this is the structure of graphite. In graphite, each carbon atom forms covalent bonds to three others. Okay, but in diamond, each carbon atom forms covalent bonds with four carbon atoms. Okay, so in graphite, these rings form flat sheets that lie on top of each other. They are held together by weak forces. That is why it is not hard. It is soft because they are held together by weak forces, and the layers can slide over each other. That's why they are slippery. Graphite is slippery. Okay, so this is the structure of graphite. So you have to draw this structure also and this structure also. And then the properties of graphite. Write it down.
That one I will.
I'm done.
So let's end the session here.